In the last video, we talked about negative, positive, and zero indices and the rules of indices that are required for multiplication and division of indices that are different but have the same basis. Now, we will talk about indices within brackets that are further powered out of the brackets. For example, we have a number like 2 to the power of 4, and it is the within bracket, and the bracket is raised to the power of 3. Now what shall we do? Now you should remember that this and this, they are completely different things. This and this are different things. This here means 2 to the power of 4 is further raised to the power of 3. But this means 2 to the power of 4 is multiplied by itself once, not thrice, but then it's multiplied by 3. But here it means 2 to the power of 4 is being multiplied by itself thrice. So to expand it, we can say that this is equal to 2 to the power of 4 is 2 to the 4 to the 8 to the 16. This means it is 16 to the power of 3, because we have just calculated 2 to the power of 4. And here it will mean 3 times 2 to the power of 4, which is again 16. Now this thing, if you calculate it further, you get 16 times 3, because bracket, when there's a number and within a bracket and a number outside, but they have nothing in between, that means we are multiplying them. So 3 16s are 48. This here becomes 48. So now the other thing, this means 16 to the power of 3, which is 16 times 16 times 16, and that gives you 4096. That means they both are completely different things. Now, what are the general rules about calculating numbers within brackets which are already powered, and then outside of bracket we have to power them by a different number again? The rule should be this. That means if a number is being raised to the power of x within bracket, and outside it's again being raised to the power of another number like y here, the final answer shall be the same number with the powers being multiplied. Now again, this rule shall not be confused with the other rule, that of multiplication and divisions, because if you remember, in multiplication we are using like this, if they are same bases which are being multiplied with different powers. Like in the first part of the video about indices, we had discussed this. The answer will be a to the power. The answer will be a to the power of the sum of x and y. But here, this is different thing. This is a number being powered by x, then further the whole bracket is being powered by y. That means we are multiplying the powers, and here there are two bases and they are being multiplied. The answer will be this one base, because it's the same thing, a, but the power is being added. So these both rules shall not be confused with each other. So applying this rule, the multiplication rule, the multiplication of so the power within bracket and outside bracket, which is raised to the power of a different number again, we can have this example: 3 to the power of 4 bracket to the power of 2. Here the simple thing we shall do is we will multiply the powers. So the answer shall be 3 to the power 4 times 2, you get 8. So 3 to the power of 8 shall be the answer in the form of exponents or powers or indices. Again, this shall not be confused with this thing, 3 to the power of 4 multiplied by 3 to the power of 2, which is equal to the sum of the power, because when base is the same and you're multiplying two numbers with the same bases but different powers, there you'll be adding up the powers. So the answer shall be here 3 to the power of 4 plus 6. What do you get? 4 plus 2, sorry, you get 6. You get 6. So the answer shall be 3 to the power of 6. That means this and this are completely different things and shall not be confused with each other. We can use a different example. We can either use a variable like a to the power of 2, b to the power of 3, and the coefficient shall be, let's say, 2. Now the whole thing is being powered by 4. Now expanding this out, you shall be, because 2 is being multiplied by a square, which is being multiplied by b cube. Now this thing again means all of this stuff is being multiplied by itself 4 times. That means each of them will get this power. The ones which do not have any power shown means that that is being raised to the power of 1, and we simply put this, the outside power of bracket, to this. And the ones which already have, like 2 with a, the power of 2 with a, you apply the rule that outside power, the power outside and the power inside the bracket shall be multiplied. So 4 will be multiplied by 2 for a, multiplied by 3 for b, and for 2 it will be directly 4. Or you can say if there is nothing, that means there is 1, because when there is no power shown, the number has the power of 1. Since the power of 0 will be equal to 1, so it is 2. That means if the power is not 0, it's 1. And so now this shall be equal to 2 to the power of 4, and a's power is 2, so 2 and 4 to 4 2's give you 8, and b 3 4's give you 12. Expanding it further, you get 2 to the power of 4 means 16. 2 to the 4 for 2 to the 8 to the 16. So the answer for this shall be 16a powered 8 times b powered 12. This shall be your answer. Another rule, that of indices, which we have to discuss here, is the powers in fractions. How shall we deal with them? Like this, for example, you have a number 2 to the power of 3 by 2. What does it mean? It means that 2 is being powered by 3, and then it's being rooted by the denominator in the power, which is 2 in this case. So this can be put in the form of this: 2 to the power of 3 rooted by 2. And then whatever the answer is, you can get after calculating it. Now you can have another example like this: 3 2 over 3. That means 3, the base, is being powered by 2 and then rooted by 3. This can be put in this form, and then rooted by 3. Cube rooted, that means. So here we can see one thing, that if a number is being raised to the power of 1 by 2, that means the thing, because the denominator here is 2. This means when any number is being raised to power of any fraction which has a denominator of 2, it shall be square rooted. And the one which has a denominator of 3 in the power in a fraction will be cube rooted. For example, let's say we have an example of this: 8 to the power of 1 by 2. 8 to the power of 1 by 3. And 16 to the power of 1 by 2. So 8 to the power of 1 by 3 will mean 8 powered by 1 rooted by 3. That means cube rooted. Here it will mean 16 powered by 1 rooted by 2. That means square rooted. So cube root of 8 shall be 2, because 2 is the number which you multiply by itself thrice. 2 times 2 times 2, you get 8. And the square root of 16 is 4, because 4 is the number which you multiply by itself twice, you get 16. There you go. And now the questions that can come up in the question paper can be of different sorts, and we shall go through them one by one. So the general rule for fractions as powers shall be this: if any number is powered by a fraction which has a numerator of x and denominator of y, it can be put in the form of the base number a here, or by numerator rooted by denominator. This shall be the general rule for such questions, and we'll be using the rules we've discussed in the questions we are going to attempt. So you can get a question like this: 625 to the power of 1 over 4. This means 625 is being rooted by 4 and powered by 1, which means only 625. So to find this out, what is the number that is being multiplied by itself 4 times, that gives you 625. One way of factorization without calculator is like you draw 2 lines, you put in the number here, and start dividing the number with prime numbers, which you call prime factorization. So here you can see the last digit is 5, so it can be divided by 5 if you remember the divisibility tests. So 5 12s are 60, 5 12s give you 60, 1 is borrowed, 15, 5 3s are and 5 5s are 25. 2 borrowed, okay. So okay, now this is 125 again, the last digit is 5 and it can be divided by 5. So 5 twice gives you 10, 2 borrowed by 5, then you're left with 25 again, 5 5s are 25. You're left with 25 again, last digit is 5, 5 can be used again. 5 times 5 gives you 25 again. 5 times 1 gives you 5. So 1 is the last number, that means factorization has ended. This shows you 5 times 5 times 5 times 5. That means 625 is equal to 5 to the power of 4, because here we can see 5 times 5 is 125, 125 times 5 is 5 times 5 is 25, 25 times 5 is 125, and 125 times 5 gives you 625. That means 5 times 5 times 5 times 5 times 5 gives you 625. So 5 to the power 4 is 625. Therefore we can replace this 625 by 5 to the power of 4 here, and then 4 and 4 cancels each other. The power and the root numbers can cancel each other the way you simplify a fraction, the numerator and denominator, and then what are you left with? This sign also will disappear if these both are completely cancelled, and you're left with 5. So 625 to the power of 1 over 4 gives you 5. You can have another question. We can say 343 to the power of 1 over 3. This means 343 to the power of 1 rooted by 3, that means cube rooted. So what is the cube root of 343? And factorizing again, (343) comes in the table of 7. 7 times 49 gives you 343. Again 7 times 7 gives you 49. Again 7 times 1 gives you 7. So this shows that 7 times 7 times 7 gives you 49. Sorry, 343. And 7 times 7 times 7 means 7 to the power of 3, which is 343. So therefore 343 can be replaced by 7 to the power of 3, the symbols above here. Now 3 and this root symbol with 3 here can be cancelled. You're left with 7. 7 is the answer. We might come across a question like this: 32 to the power of 3 over 5. This means 32 is powered by 3 rooted by 5. Now in questions as such, we can use multiple rules which we have learned about indices. So first we will factorize 32. See what happens. 32 can be divided by 2 because the last digit is even. 2 16s gives you 32. 2 8s give you 16. 2 4s give you 8. 2 2s give you 4. And 2 1 gives you 2. So here you're left with how many 2s? 2 times 2 4, 4 times 2 8, 8 times 2 16, 16 times 2 32. This means 2 is being multiplied by 5, 2 is being powered by 5 to give you 32. So here we can replace 2 to the power of 5 because we have just calculated that 2 to the power of 5 is 32. We can replace this with this. The rest of the things can remain as they were. Now here we can cancel this 5 with this 5. Even if you see, before going into this step, we can factorize 32 directly before putting the root symbol. It's because 32 was, we had calculated earlier, that is equal to 2 to the power of 5. So 2 to the power of 5, if it's being multiplied by 3 to the power of 5, and we know, as we learned in the rule of multiplying the powers, as in this case, the powers multiply if they are inside the bracket and the other is outside the bracket. If you remember the rule, according to that thing, 5 here shall be multiplied by 3 over 5, and when you multiply a number, a fraction like this, 5 can be either cancelled with, can be cut with the numerator or the number that is being multiplied by the numerator. Therefore 5 and 5 will cancel each other. We are left with 2 to the power of 3. Even in this case we are left with 2 to the power of 3, and 2 to the power of 3 will give you 8. That's the answer for 32 to the power of 3 over 5. We might come across the questions that are further complex, like this: 4 to the power of 5 over 6 times 4 to the power of 1 over 6 divided by 4 to the power of 1 over 2. Now we can use different rules here to work out this question. What we can do here is convert 4 in the powers of 2 like this, because 4 is 2 to the power of 2. We can replace all 4s with 2 to the power of 2 to make calculations easier. So here we can say 2 to the power of 2 is being powered by 5 over 6 times 2 to the power of 2 again is being powered by 1 over 6 over 2 to the power of 2 powered by 1 over 2. And remembering that rule again, that if a number is being powered by a number within bracket and this is a power outside the bracket, we shall multiply the powers. The answer shall be in this form. The base will remain the same and powers will multiply. So using that rule again, we will multiply these powers here, these powers here, these powers here. And as we know that the numerators and denominators can cancel out each other, or the numbers that are being multiplied by the numerators can be cancelled with the denominators. So 2 times 1 and 2 times 3, cancelling them out. Here 2 times 1, 2 times 3 again, 2 times 1 and 2 times 1. Now since we have cancelled numbers out, we are left with this. Here we are left with 2 to the power of 5 over 3 times 2 to the power of 1 over 3 over 2 to the power of 1, because this 2 and this 2 was cancelled. Now remembering the rule we had learned in the first part about indices, that if we have the same base which are being multiplied but they have different powers, then you add them up. According to that rule, we shall add these up, and adding them up we will get 2. The powers will add up if we are multiplying the numbers with the same base. So 2 and 2 are the same bases but powers are different and they are being multiplied. So 5 over 3 plus summed up with 1 over 3 gives you 6 over 3. So 2 to the power of 6 over 3 over 2 to the power of 1, which is 2 itself. Now 6 over 3 can be cancelled. 3 times 1 3, 3 times 2 6. So we are left with 2 to the power of 2, because 2, this is equal to 2 to the power of 2, because 2 over 1 is 2, and as a denominator we have only 2 here. So 2 to the power of 2 gives you 4, and denominator is 2, and cancelling them out, 2 times 1 2, 2 times 2 4, you're left with 2 only as your answer. So these were all the rules which are required to calculate indices and the questions that have different forms of indices. Now summing up all the rules, we have to know that some questions require different rules to be applied and other only require one of the rules. So as for positive indices, we know that if a number is being powered by another number like 2 to the power of 3, this means 2 is being multiplied by itself thrice. Then we have a negative index, negative power, like let's say a to the power of minus 2. This will mean here a will have the power of 2, except that it will be reciprocated. Due to this minus symbol, we shall remember that the number will be under 1. The number will become a denominator, and due to this negative symbol, negative power, the number shall become a denominator. Another rule is any number raised to the power of 0 gives you 1, whether it's 100 raised to the power of 0, 10 raised to the power of 0, 5 raised to the power of 0, anything. Another rule is when you multiply numbers with same bases but with different powers or indices, the answer will be the same base, that base powered by the sum of their powers. Another rule is, now since this symbol can be replaced by division symbol, this plus shall be replaced by minus. So a number raised to the power of x divided by another number raised to the power, the same number being raised to another number. The rule for this, the general rule shall be the answer being in the form of the same base, except the first power shall subtract the second power. And the last two rules are, when we have a number in bracket with a power and the bracket outside is also being powered by a different number, here we shall multiply the powers and open up the bracket with the same base. And another rule is that when a number is being powered by a fraction, that means that base number will be put in the form of the number to the power of numerator rooted by denominator. And that's all for indices.